Okay, so here we go with quadratic formula. I've written out the quadratic formula here, and I have a quadratic equation in general form. Does not factor. There are no factors of 10 whose difference is 2. So we're going to go ahead and use the quadratic formula. So naturally, I would have the opposite of b, which is this number here. So the opposite of b plus or minus the square root of b squared. I'll write in all my parentheses like a good little student here. Minus 4ac all over 2a. So I already have the b written in. So negative 2 goes here because that's my b squared. A is the coefficient here. So 4ac is a negative 10. And then a again is 1. So this is what the expression looks like when we first fill it out. So we would say, all right, the opposite of negative 2 is 2 plus or minus the square root of, let's see, negative 2 times negative 2 is 4. Negative 4 times 1 times negative 10, that gives us a positive 40. And that's all over 2. So after this, we just continue to simplify. So 4 plus 4, that gives me a 40. A 44, actually, all over 2. And radical 44 simplifies. That just becomes 4 times 2 radical 11 all over 2. And when I simplify that, when I reduce it, I have 1 plus or minus the square root of 11. So we have two solutions here, 1 plus the square root of 11 and 1 minus the square root of 11. So that makes sense because we have a quadratic equation. So this is a kind of easy one for us. So let's look at one that's a little bit more medium. Okay, so here we have another quadratic equation. I don't think it factors. I don't have any greatest common factors that I can take out of it. So I'm going to go ahead and use the quadratic formula. The opposite of b plus or minus the square root of b squared minus 4 times a times c. So, and that's going to be all over 2 times a. Whoops, I almost wrote a in there. A. So let's see, b is 12. So 12 goes here. A is 4. So 4a all over 2a. And c, that's my minus 5 up here. So I have all my substitutions made. So now I just have to do some simplifying here. So let's see, I know that's going to be all over 8. Negative 12 plus or minus. Let's see, 12 squared is 144. 4 times 4 is 16 times 5 is 80. And it's negative times negative, so that's going to be a plus 80. So in my next step, I guess I could add 144 and 80. And I'd get, let's see, 224 all over 8. And 224 is divisible by 16, I do believe. So I'd have negative 12 plus or minus 4, because that's the square root of 16. And 16 times 14 is what equals 224. And I'll put that all over 8. Running out of room here, so I'll bring it up here. So negative 12 and 8, well, 4 goes into everything evenly here. So we'd have negative 3, because 4 goes into negative 12 negative 3 times. 4 goes into 4 once. And last but not least, 4 goes into 8 twice. So this would be my final solution. -3 plus or minus the square root of 14 all over 2. So that one's a little bit trickier because we ended up with a radical. But it's the first one was a little bit easier. Let's look at one that's maybe a little bit harder and more difficult to solve, maybe even has an imaginary solution. So here's our third example. This one's going to result in an imaginary complex solution, so complex conjugates. And if you're getting value out of this, please go ahead and hit the like button. Or more importantly, share it with a friend who you think could benefit from this content. So we're going to go ahead and use the quadratic formula again. So the opposite of b, remembering that b is -1. So the opposite of b, and this is why I always put parentheses in, because I don't want to confuse this negative with this negative. This is part of the formula. So plus or minus the square root of, let's see, b squared, well, I put my -1 in, minus 4 times a times c. And that's going to be all over 2 times a. So again, b is -1, which I already put in here. So I have it in both places. 4 times a, so 2 is a. C is a positive 9. And down here we get an a also. So a is 2. So far, so good. The opposite of -1 is 1. Plus or minus, let's see, the square root of -1 times -1, that gives me a 1. Minus 4 times 2 is 8, and 8 times 9, that's 72. And that's all over 2 times 2, or 4. So you can see what's happening here. We have 1 plus or minus the square root of a negative number. So 1 minus 72, that's -71. So cannot take the square root of a negative number, so we have to extract that I. So I'd have 1 plus or minus I times the square root of 71. So 71 doesn't have any factors that are perfect squares. In fact, it's prime, so I can just leave it as that. And that's all over 4. So we have 1 plus I times the square root of 71. And we have all over 4. And we have 1 minus I times the square root of 71. All over 4. And the reason I'm writing those out is because, remember, whenever you get an imaginary, a complex answer, they're always going to be complex conjugates, because zeros in polynomials, all polynomials, end up being conjugate pairs if they are imaginary. So that's it for this one. So until the next time, this is Mr. Nolde signing out. So that's all I had for today, an easy, a medium, and a hard-ish problem that uses quadratic formula. So this gets used whenever we can't factor or don't know the factors. This will work even if a function factors. If a quadratic factors, you can still use this. So, but anyway, we usually use it when you don't know how something factors. So again, hope you've gotten value out of that. Please go ahead and hit the like button down below. Share it with a friend who you think could benefit from it. And lastly, go ahead and subscribe to the channel. I'd appreciate that. And until the next time, I hope everything's going great in your classes. I hope that you are studying hard, studying your notes, doing your assignments. Keep that up, and I promise you will do really, really well in your Algebra 2 or pre-calculus class.